Hello everyone, my name is Hars, and in this video we're going to be going through LeetCode number 20, valid parentheses. Given a string S containing just the characters for round brackets, curly brackets, and square brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So these are the three cases that we have to consider when determining if a string is valid. So let's go through a few examples. So for the first input string, we see that we have an opening round bracket, but it's immediately closed by a closing round bracket. So this part of the input string is valid. Similarly, we see a opening square bracket, but it's immediately closed by a closing square bracket. So this part of the input string is also valid. Finally, we have a opening curly bracket, and that's also closed by a closing curly bracket. So the rest of the string is also valid. And since each part of the input string is valid, that means we have a valid input string. However, if we look at the second example, we see we have an opening round brackets, but we have a closing square brackets. Now this input string is both opened and closed correctly, so it meets one of the conditions, but the opening and closing parentheses are not equal. For this input string to be valid, we would either need to have opening and closing round brackets or opening and closing square brackets. So to come up with a solution, we can leverage the use of a data structure called a stack. Now, if you don't know what a stack is a last in, first out data structure. So for this data structure, you can imagine a stack of anything. For example, a stack of plates. So we can go ahead and add plates one by one into the stack. So when we add one plate, it goes to the bottom of the stack. But when we add another plate to the stack, we see that it's at the top of the stack. And we can go ahead and continue adding more and more plates into the stack. But when we want to remove a plate from the stack, we take it from the top of the stack. And we can't take a plate from the middle of the stack since the plates above it will be smashed. So we call this data structure a last in, first out data structure. So when we add it to the stack, it's last in, and when we take it out, it's first out. So how can we use this data structure to solve the problem? Well, we can keep a stack of all the parentheses that we see. So consider the same string that we looked at previously. If we add a parentheses to the stack, we can see that we begin by adding the opening round bracket. But whenever we see a closing bracket, in this case, it's a round closing bracket, we want to try and pop the last element from the stack. If we see that the popped element is the matching pair for the parentheses, we know that we have a valid pair. So when we encounter this round bracket, we're going to pop this element from the stack. And since it was matching with the other round bracket, we know that we can successfully pop it and that we have valid parentheses until this point. And similarly, if we continue with the remaining string, we'll see that the same pattern continues. Now let's consider the second example. First, we see that we have an opening round bracket, so we can add it to the stack. Then we see we have a closing square bracket. So we try to pop the last element from the stack. So we keep this in a variable, we can say last, and we'll keep it as an opening round bracket. However, the square bracket does not match the round bracket. So we see that the parentheses are not valid. and it only requires one invalid pair to deem the entire input string invalid. We can also consider the edge case where we pop from an empty stack. So let's consider one square bracket that's only closing, and it has no opening square bracket. Well, if we have this, we're trying to pop from an empty stack, which is already not possible. So if the length of the stack is 0 and we find a closing bracket, we already know that it's an invalid parentheses. So these are all the cases that we need to determine whether or not the input string is valid. And if we discuss the time complexity for this algorithm, we see that it's big O of n time, since we need to go through each of the characters in the input string, where n is the length of the input string, and then the space complexity is also big O of n, since we need to maintain a stack. So using this intuition, we can go ahead and write the code for this algorithm. So we're on LeetCode right now, and we can start writing the code. To represent the stack in this problem, we can just use a list. That's because appending and popping from the end of the list will have a worst case time complexity of big O of 1. So we can just say stack is equal to the empty list. Then we want to iterate over each bracket in the input string. So we can say for p in s, then we want to check if it's a opening bracket, so a opening round, curly, or square brackets. Then we can just check to see if p is in the list of opening round brackets, opening curly brackets, and opening square brackets. If it's in this list, we just want to append the bracket into the stack. Then at this point, if we know that it's not a opening bracket, it has to be a closing bracket. We know that we can't pop from an empty stack, so if we see that the length of the stack is 0, we can just return false right away, since the input string is invalid. So we can say if the length of the stack, if it's 0, then we have an invalid input string. Finally, we know at this point we have something in the stack, but we need to make sure that it matches the closing brackets. So we can keep track of the last element. So we'll just pop it from the stack. We'll just check to see if the last matches the closing brackets. So if last is a opening round brackets, and p is not a closing round bracket, then we're going to return false. That means the closing bracket was either curly or square. So we can check all the other conditions as well. So we can do the same for opening curly, and if it's not a closing curly brackets, or the last is an opening square and p does not equal closing square brackets. If any of these are true, then we can just return false. Finally, we need to make sure if the stack is empty. If it's not empty, that means we have more opening brackets and that have not been popped. And that means there's a mismatch of parentheses, so the input string is invalid. So we can just say if we return the length of the stack when it's 0. And if it's 0, we return true. If it's not, we return false. So this should be the entirety of the code. So we can go ahead and submit it. And as you can see, it's accepted. So the time complexity for this solution is big O of n, and the space complexity is also big O of n. Hopefully this video helped you and you learned something, and I'll see you soon.